This is going to be a rather lengthy video, but it's going to be very useful for understanding UMLs and adding a couple of new elements to our code, such as constraints using classes and static variables. We'll implement in this one, but we will see it in the next video, I believe. So the first thing before we dive into the pet UML, which you can find the resources for on Blackboard, is I want to show you the temperature demo. So we know it worked. We could type in a temperature of 10 or whatever we'd like, and we would get the Celsius, Kelvin, and there's our other Celsius we threw in there. Let me comment that out. I could say the temperature is negative 5,000 or 50,000. Probably don't want a negative 50,000 temperature, maybe, but there should probably be some constraints to tell me what's too high, what's too low, what's acceptable, and what's not. Well, that's what we're going to do in this new UML called pet. So the first thing we're going to do is we are going to make that Java main class, or sorry, just Java class, pet. And let me make sure I put this in the correct location. And after some moving around, I have pet, which is just the class, and then I have pet demo, which is of course the main class, which will run the pet code. And here is our UML that we're going to build. We can see that this is the UML, right? We've learned how to read these over the past few examples. We also have some notes. If the age or weight is less than 0, print an error message and end the program. Must be done using multiple constructors or methods. If the constructor used has no value for name, we can increment without name, and toString should neatly print. So let me explain these real quick. We're going to have an if statement that says if the age or weight is less than 0, that's invalid. We're going to end the program. You can't have a pet with those data points. We are going to have a static variable called without name, and whenever we make a pet or we invoke a constructor that doesn't use a name variable, we will increment that because that is just shared data point, right? So we will count how many pets do not have a name through the use of that static variable paired with the constructors, and we will have a toString method that prints our pets as we see here. So let's see. It may differ a little bit from the image. This, I believe, is for another example, but we will complete these instructions. So let's fill out the pet UML, and as per usual, we're not going to worry about what's inside the methods or variables, we're just going to create them. So it looks like we have a private string called name. So a private string called name. I believe I also saw a private int called age, a private double of weight, and a public static int without name. Those are the variables I saw. And that is correct. I knew that without name was static because it is underlined. So that's how you tell that a variable is static, is because it's underlined as seen here. Let me zoom in on this. We then have 1, 2, 3, 4, 5 constructors. So let's create all of those. The first one is our default constructor. I'm gonna copy the word constructor. Just gonna be typing that a lot. Public pet, a default constructor, takes no arguments, of course. We then have fully overloaded, so all pet data would be public pet. And what does the UML tell us about this? It tells us that it wants an age, a weight, or a name, an age, and a weight. It's a little weird reading it backwards like that. So it wants a string of n, an int of a, and a double of w. Okay, there we go. We'll fill this out in a little bit. There was also another constructor there that was calling for just a name. So this would be public pet string n. Constructor. I believe there was a couple more, right? Yep, just a age and just a weight. So just age and just weight constructors, public pet int a, and public pet double w. So if I zoom out here, you can see that we have 5 constructors, and you can pause the video if you want to copy these down. The code will also be available on Blackboard after. We're going to continue onto the methods before filling any of this out. So the methods are likely to be our setters and getters. Let's take a look. Yep, we have a set name, which takes a string of new name and is void. So how do we want to write these? Let's do all of our sets together and all of our gets together. So let's say setters, and then we'll do name, public, void, set name, takes a string of new name, and looks like this. Yep. And then we can do age, which would be the exact same thing, probably takes new age as an integer, and is called set age. And last but not least, we'll do weight, which would be set weight, and takes a double of new weight. Let's reassure that that is correct. They're all void. Yep, be careful when you're copying and pasting. I am probably the first person to make mistakes of not renaming the variables correctly. Let me capitalize this, just so I can see everywhere in my code. The getters, we are going to have a public string of get name, which will return name, I believe. Yep, get name returns a string, and that would be name. So we'll have name, age, and weight. This will be get age, returns age. This will be get weight, returns weight as a double, and an int. So all of our getters are done. Their return types are as shown. And then we need a, oh, and I threw the return types in without even thinking, right? But that's okay for now. If we have to change anything later, we will. But that should be okay. They should just return. Now let's move on to the last method, which would be toString. So let's do a public string toString method. We will throw in the override as that is built into Java. We have a red line. Because I already returned the variables here, let's go ahead and fix that by simply returning a blank string for now. We will adapt this later, but just to make it happy. So I can't zoom out too far, but hopefully that is somewhat visible. Maybe you might have to maximize your screen, but you can see that we do match up with the UML diagram here. We have the 5 constructors, our setters, and our getters. Now we just have to write the code itself. So let's go ahead and do that. I'm going to walk you through this because there is a lack of instructions on what to do for the names and things like that. So what I'm going to do here is I'm going to say name is no name yet, meaning if you invoke the default constructor, right, this blank pet, the name is no name yet because you didn't give me any information about that pet, so it has no name yet. Its age will be 0, its weight will be 0 or 0.0, however you want to put it. And let's see, does this pet have a name? Well, no name yet, no. So we would increment without name. Remember that instruction in here. If there's no value for the name, we increment that variable. That is this case. So let's go ahead and move on with our constructors. In this one, we have all of the information. So we can go ahead and say that name equals n, basically private equals public for everything. Age equals a, weight equals w. Does this pet have a name? Yes, it does. So there is no need for us to increment without name because we have that name variable. This pet only has a name, so name equals n, age equals 0, weight equals 0.0. We don't know any of the other information. It does have a name, so we're not going to increment without name. This pet only has an age, so name equals no name yet, age equals age, whatever you give me, A, weight equals 0.0, and without name plus plus, because if you invoke this constructor, I don't know the name. Same for weight, we can start out by saying we don't know the name, we increment name, we say name equals no name yet, because we don't know that, that's why we're incrementing. Age equals 0, and weight equals W, because we do know the value of weight here, right? So that's all of our constructors set up. If we have no information on the pet, if we have all the information on the pet, just the name, just the age, just the weight. Now let's do our setters. So for our setters, what we're going to do is we are going to say private equals public, just like we did in the constructor. But make sure you watch the whole video to see the issue that this causes and the fix to that very issue. So here we can just say name equals new name. And here we can say age equals new age. Private equals public is how I like to say it. It's nice and easy to remember whenever you're working with setters. Weight equals new weight. Okay, so we have our entire class. We just need the nicely formatted string. So here I'm going to return name, name, age, years, \n, come down to this line, weight would be weight, and that is pounds. Okay, so if we come over to our main class, we can see that nothing happens. So let's write a demo class here. So what I want to do first is demonstrate that all of our constructors work. So I'm going to make a pet, and I'm going to call it pet1 equals new pet, and we will call it Jane Doe, just as we saw in the UML example here. So my records for your pet are incomplete. So let's go ahead and write that. My records for your pet are incomplete. And then we'll ask the user to fill out the pet's information. So here is Jane Doe. We then want to print the pet. Here it is. My records for your pet are incomplete. Name, Jane Doe. Age is 0 years. Weight is 0 pounds. Let's fix some of that formatting. That would be here. And this. That should fix it. So we can see that the record is incomplete because 0 years and 0 pounds is all the information we have on the animal. So let's go a step further, bring in a scanner. Then we'll create the variables we need to complete this pet. So we need a name, an int for an age, and an int, or a double, for a weight. Right, so we're going to allow the user to define this pet object here. And I'll show you just how we can do that. We can do that by saying something along the lines of, please update the following. Then it's going to prompt the user nicely to enter pet name. In case they want to update that pet's name, we can say name equals scan dot next line to read it in as a string. Can then do a little bit of copy and pasting here. Change this to weight, this to double, this to int, age, weight. And this will be get the new information for the pet. Okay, so we asked the user for a name if it's changed, the age and the weight. And then what we're going to do is we are going to create new pet object based on user's input. So we can take that pet1 that we just created up there, equals a new pet, and give it the fully loaded constructor. Okay, so when we first created our original pet, pet1, we gave it just a name. So the constructor that was invoked was this one. This constructor was invoked, assigning the name to n and giving age and weight 0 values. We then prompt the user for all of the missing information, and then create a new object based on the name, age, and weight. When we do that, we are then invoking this constructor, because it takes a name, age, and weight. So with that, what we can do is we can say pet record updated and show the user their new pet information. Right, so here we go. My records for your pet are incomplete. Jane Doe is 0 years old, 0 pounds. Please update the following. The pet name is now Tony. The age is 6, and the weight is 12.2 pounds. And there we go. We updated it based on user-defined input and invoked this constructor based on that. Pretty cool. And not too challenging, hopefully. Now, let's look into where things could go wrong. So my pet's name is Apples, and its age is actually negative 50 years old, and it weighs negative 1 pound. It's a feather, lighter than a feather. Well, this should not be acceptable, right? As seen in the UML originally, we need to get something like error, negative age or weight. So if the age or weight is less than 0, print an error message and end the program. So we're going to have to do that among multiple constructors, as it says here. I'm going to show you a couple ways to do that. So the first thing that we could do is inside of, let's see, this is default, so we don't need to do it here. We would need to do it when we get an age, right? So if we get an age, what we're going to do, instead of saying age equals A, we're going to do a little bit of work to ensure that this is acceptable. We're going to say, let me move this up here, if A is less than 0, do something, else do something else. So if age is less than 0, we're going to print a system.err.println. And what ERR does is it prints the message in red. You'll see, it's pretty cool. It just shows it as an error message. Error, invalid age. And that will, we can assign the age to be 0. Instead of ending the program, we'll just assign the age to be 0. Else, it means that the age is 0 or greater. We can say age equals A. Right, so before, all we had was age equals A. But this doesn't check for an invalid age. What this does is it says if the user tells me the pet's age, I'm going to check if that age is less than 0. If it is, tell them that's invalid and set the age to be 0. Otherwise, the age is whatever they said it was. We're going to do something super similar with where only we get weight. So if W is less than 0, if the weight you tell me is less than 0, do this. Otherwise, do this. If weight is less than 0, we are going to just take this code, invalid weight, and weight equals 0.0. Okay. We are also going to have to do it for the fully overloaded constructor, which is the one we care about right now, which is this one. So we can do something along the lines here of if A is less than 0, or, because it doesn't have to be and, only one has to be wrong, right? If A is less than 0, or W is less than 0. Error, invalid age, or weight, we don't care which. And we'll just go ahead and assign both to 0 for simplicity. If one of them's wrong, we'll just assign both to 0. We could do it the other way around. I mean, we could make it more complicated and check which one is wrong and blah, blah, blah. But we're not going to get into that just yet. I just want to show you the if statements here. Else, age is what you tell me it is, and weight is what you tell me it is. We don't have to perform a check for name. Let's add some comments. Check valid age and check valid weight. Okay, so if I run this, into my pet's name is Tony, negative 500, and weight is -5. Pet record updated, error, invalid age or weight. Tony is 0 years old and weighs 0 pounds. Because I gave it invalid data for age and weight, when it invoked that constructor, what actually happened was it hit the if statement. It determined that this was true, one of these, actually both, but it determined the A first. It said this message as an error message, that's why we see it in red down here, and assigned the values as such. So there is a little bit of an issue here, because I could kind of hack the system. Pause the video and ask yourself, how could we hack the system here? I could potentially get my pet to be negative 5,000 years old. How could I do that? So pause the video real quick and try to figure out how you can get the pet to be negative 5,000 years old with our current state of the program. So if you paused and tried to figure it out, good job, either way, but let me show you how we could do that. So what I could do is I could say, okay, invalid age, whatever, pet1 dot set age negative 5,000, print pet1. Let's see, Tony, age is negative 5,000, weight is, doesn't matter. So what we see in the output here is Tony is negative 5,000, that's invalid, so here's your pet record 00, but then I get negative 5,000 years old. So we kind of hacked our system, right, because it's of course not foolproof, and that's through the use of the set age method. So the set age method right here, what it does is when you call it, it just sets private to public. So whatever you give it, it will take and change it. There's no if statement in play here. And that's why when we invoke the constructor, it caught it. So after it was caught, I knew the setAge method didn't have that if inside of it. So I just ran the setAge method, and there's my invalid pet. Now, how we could get around this is we could simply just take this code and place it in setAge. We just have to change this to new age, and this to new age. We could do the same thing for the weight, and we would just have to change this to new weight, and this to new weight. And I believe those are the only places we would have to do it. Tony, negative 5,000, doesn't matter, and there we go. We can no longer hack the system because our set methods include that if statement. Now, how could I clean this code up? Let me keep that in there for now. How could I clean this code up? Well, I have the same if statement multiple times, right? I have the same if here as I do in the set age. So if set age is now taking care of a valid age, why don't I just call the set age method right here? So we could say set age, oh, not here, sorry. It would be in this one. So instead of this entire if statement, we can call set age passing it A. And we could do the same for weight. Instead of this entire if statement, we can call the set weight method passing it W. Because when you call set weight, what you actually do is you invoke this method. So why have it as an if statement when you can just call the method directly? Let's do this again. And there we go. We get the invalid age here. Now to simplify this even more, what we could actually do is instead of having this ginormous if statement right here, I believe we can get away with calling set age, passing it A, and set weight, passing it W. You are going to get yellow lines here. I'll explain them in a second. Let's try this again. Tony, negative 5,000. We'll pass 1 for the weight, and you get an invalid age, which is good, and it actually fixes our issue. Yep, it fixes our issue where we don't set both things to 0, now only one of them is. So let's talk about the yellow line real quick, because we are running pretty deep into this video. It's going to tell you that the overridable method call in constructor, and that can be dangerous because users could potentially inject code into these methods that we don't want them to. And for us, we don't have to worry about it right now. If you get into web design where you connect this to a database or something, maybe, but for our purposes, don't worry about it too much. It just means there is a potential to crash the program because the user is accessing a method through the constructor. So if you know how the methods work, you could invoke the constructor, pass something bad to the method, and then crash the program. But again, for our purposes, I would not worry too much about it at this point in time. But this looks exactly what we want. Yeah, this is exactly what we wanted to happen. So this is how if statements can be implemented into a class. We will see more of this in future examples. Hopefully this made sense. There was a lot to go on here. We will talk about the without name variable, which is static, in the next video, which will be a lot shorter than this, I promise.